What's up, 10C? This is the first lesson in the new unit, which is on equations of a line, and this is on parallel and perpendicular lines. Some things to know about this new unit. It's probably one of the most important because it teaches you a lot of problem-solving skills that you will need, especially if you're going into 20-1. With that being said, it's probably going to be a harder unit to learn from a distance, so if you're having questions, you need to let me know. And I am cutting it down a little bit in terms of the complexity, just because it is hard to teach those harder problem-solving questions from a distance. Okay, so let's get started. So it says here, in the example to the right, both lines have a rise. So here's line AB, and here's line CD. Both of them have a rise of 7, right, and a run of 5. Therefore, both lines have a slope of 7 over 5. Remember, if you're given a graph, you can find the slope by using m is equal to the rise over the run. So if they both have the same slope, we say that line AB is parallel to line CD, which means those two lines will never intersect with each other. So, which means the lines will never intersect. On top of two lines being parallel, which means they don't intersect, kind of like, train tracks, they won't intersect. And if two lines are parallel, they have the same slope. They have the same slope. So non-parallel lines then would just have different slopes. And so some things we also need to remember from the previous unit is that m is equal to rise over run, and we generally use this to find slope if we're given a graph. The other one is m is equal to y2 minus y1 over x2 minus x1. And we would generally use that if we are given like data points or a chart. And we can then use that information to help us figure out the slope. Okay, so the big thing I guess to take away from this first slide is that if two lines are parallel, they will have the same slope. So let's go look at an example. It says, sketch the lines and calculate the slope. Are they parallel? And then justify your answer. So we're going to go sketch each of these and then we'll compare their slopes after to determine whether or not they're parallel. So it says line EF passes through -3, -2. So that's this point right here. And F is at -1, 6. So right there, that would be point F. And whatever line, we have some sort of a straight line, even though in mine it's not straight, joining those 2 points. So what is the slope? Well, the slope would be a rise of 1, 2, 3, 4, 5, 6, 7, 8. So a rise of 8 over a run of 2. 8 over 2. And so that slope simplified, right? We always want to simplify our slopes is 4. Now let's do the next one. Line CD passes through -1, -3, which is C. Line D is at 1, 7. So there is D, and I can sketch those. Now, maybe they're parallel, maybe they're not. I'm not sure, but what I need to go do is find the rise and the run, again, of these. So a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So M for the green line is a rise of 10 over a run of 2. Well, 10 divided by 2, I'm going to simplify that to 5. So are, lines EF in red and lines CD in green parallel? No, those two lines aren't parallel. Now let's go see if we can make AB, or if AB is parallel to either one of those lines. So it says line A passes through -3 and 8. -3 and 8. -3 and 8. Oh, yes, okay, sorry. -3 and 8. Thought I had a typo there. and -5 and -2. So that's point A and B. And again, if I connect those with a line, they kind of all look like they could be parallel, but I'm not sure. So I need to go find out the exact slope. So the M here would equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over the run of 2. So the M, or the slope for line AB, is 5. And so based off of that information, apparently this line in blue and this line in green are parallel. So we would say that line CD is parallel to AB. Okay. So that's looking at parallel. So parallel lines never intersect and their slopes will be the same. Now let's take a look at this diagram here. It is two lines, and if you notice, they intersect right here, and there's a square box there. And, if we notice from, geometry, anytime you have a square box when two lines intersect, that means they intersect at 90 degrees. So these two lines, in this example, lines AB and lines CD, they intersect at 90 degrees, and mathematically, they are drawn, or what we would call, perpendicular. So line AB and CD are perpendicular, which means they intersect at 90 degrees. They intersect at 90 degrees, okay? So let's just go take a look. Let's go note what both of these slopes are. So here's line AB. It has a rise of 4 over a run of 3. That's this line right here. So M for AB, touching it twice, is equal to 4 over 3. Let's go take a look at line CD. So line CD is this line right here. And that has a negative slope because it's falling from left to right. And it's a rise of 3 over -4. And so if I kind of notice, there is a connection between these two numbers. And that's how we can tell that two lines are perpendicular. So see if you can figure out how I could convert from that fraction to that fraction. Maybe you figured it out, maybe you didn't. So there's two things to note. This, if I take that fraction and I flip it, I would get 4 over 3. And then I just need to times that by -1. And that's how I can go from one fraction to another and how I can figure out whether slopes are perpendicular. So the first thing to note is -3 over 4 is a negative reciprocal. That's what we call flipping of something, reciprocal. So -3 over 4 is a negative reciprocal of 4/3. Now, some people don't really understand, like, negative reciprocal, what does that mean? Well, really, if I take this, I times it by -1, and I flip it, that's the same thing, negative reciprocal, okay? The other thing, which is a little bit harder to note, is actually if you multiply these two slopes together, okay, multiply these two slopes together, if the lines are perpendicular and you multiply the slopes together, they will always equal -1. So you can kind of do either one to determine whether two lines are going to intersect at 90 degrees. So let's go take this knowledge and go look at an example. So what do we need to take away from here? Lines that intersect at 90 degrees are perpendicular lines, and for lines to be perpendicular, the slopes are negative reciprocals of each other. So example 2, it says, are these lines parallel, perpendicular, or neither? And sketch the lines and verify your answers. So let's go ahead and do that. So line ST, I'm going to draw in blue, passes through -2, 7, so right here, that's point S, and at 2, -5, so that's right here at point T, and I would connect that by a line segment. So there's my line. So what I need to do is figure out what is the slope of ST. So we'll do the rise over the run. So the rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, 12 over the run of negative, because I'm going backwards, 1, 2, 3, 4 over negative 4. So the slope of line ST is negative 3. So we're going to go do the same thing now for my other line, line UV. So line UV passes through negative 2, comma 3. So this point right here is point U. And through point V, which is at 7, comma 6. So this is point V, and my line that connects them looks like that. So again, I need to go find the slope, or the rise over the run. So I have a rise of... can't even tell where that point is. 3. So the M of UV is equal to a rise of 3 over a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that point's supposed to be up there. Over 9. So that's 1/3. So then the question here is asking me, are these slopes parallel, perpendicular, both, or neither? Well, how obviously these two lines, or these two slopes here are not, they're not parallel, because parallel lines have the exact same slope. So I know they're not parallel. Now I need to determine whether or not they are perpendicular. Well, what I can do is think about this. If I take negative 3 and write that as a fraction, it's over 1. So if I take that and I flip it, I would get 1/3. And times it by negative 1, right? Take the negative reciprocal. So that's a negative, a negative, which is a positive 1/3. So those two lines, that means that ST is perpendicular, that's how we represent it in like geometry terms, perpendicular to UV. Okay? Just one thing to note here, we're going to go look at slope-intercept form in a little bit more detail next lesson, but I do want to put some information out there because it's going to help us with the next few questions. So this here, y equals mx plus b, is slope-intercept form. You should learn that from grade 9. Some things we can tell about this is, as long as y right here needs to be by itself, I can tell some things about this graph. I can tell whatever is attached to x, so whatever numerical value is attached to x, that's going to be my slope. Whatever is the constant, or the number that's by itself without a variable, is going to be my y-intercept. Okay? And that's important because we're going to go help take slope and go figure out parallel and perpendicular lines given an equation. So example 3 says, determine a slope of a line that would be parallel and one that would be perpendicular to each of the lines below. So here is that y equals my. Here is that y equals mx plus b. Well, plus b is minus 9, but same thing, right? So here, the m value, or the slope of this line, is equal to 2. Or we could say, m of this line is equal to 2. They want me to go say, what is an equation, or what slope would be parallel to that? So a parallel slope, well, parallel lines mean they have the exact same slope. So the slope would be 2 of a parallel line to this given line up here. What about a slope that would be perpendicular? Well, to find a perpendicular slope, what I need to do to that 2 is times it by negative 1 and flip it. So as a fraction, 2 could be written over 1. So when I flip that, it's 1 over 2 and a negative. Okay? So take a second, maybe pause the video and see if you can try B. What would the parallel slope for B be, and what would a perpendicular slope for B, the equation B, be? Okay, so hopefully you can look at this and realize that this number right here, negative 2/3, is the slope of this equation, or the slope of this line. I can tell that because it's in this form, y equals mx plus b. So a parallel slope would have to be one that's identical to that, so a negative 2/3. A perpendicular slope means I need to take that, times it by -1, which is going to make it positive, and then flip it. So 3/2. Okay. Another example, 2y minus 4 equals 6. And they say, find a parallel and perpendicular slope. Here's where we run into a problem. Right now, I can't tell anything from this equation. Because these other forms, in order to tell slope, I need y by itself. And that's not what's happening here. So I need to get rid of everything else that's on the same side as y. So I would add 4, and what I do to one side, I do to the other, because this is an equality. So I'm left with 2y equals 6x plus 4. And to get y by itself, well, the 2 and the y are being multiplied, so I need to divide by 2. And again, what I do to one side, I do to the other. So this equation ends up with 6x divided by 2, which is 3x, and 4 divided by 2, which is 2. So here's my equation now, and now, when I have y by itself, I can go find the parallel slope and the perpendicular slope. So a parallel slope would be a line that's exactly the same, so the slope would just be 3. And a perpendicular slope means I take that 3, times it by -1, and flip it. So flipped would be 1/3 and negative. Oops. Okay, example number 4, probably the last one I'll look at, and it just says determine whether the lines are parallel, perpendicular, or neither. So here's A. I have y equals 3x minus 6, and y equals -1/3 x plus 4. So to determine whether these lines are parallel or perpendicular, I really just need to focus on the slope. So the slope here is a 3, and the slope here is a -1/3. Well, I know for sure they're not parallel because they would have to have the exact same m value, which isn't right, or which isn't happening here. Are they negative reciprocals of each other? Yeah, they are, because if I take -1/3 and flip it and times by -1, I would get 3/1. So these ones are perpendicular. B should be pretty easy. Y equals 4x plus 3, and y equals 4x minus 5. So whatever's attached to x is the slope. So the slope of the first line is 4, and the slope of the second line is 4. And if the slopes are the same, hopefully we've recognized that those two lines are parallel. Next one. C, y equals 2x plus 6, and 6x plus 3y plus 3 equals 0. Now, I can't tell. Here I can combine these equations because they all have y by itself. This is in slope-intercept form, and this is in general form, which we'll talk about later. But I need y to be by itself before I can talk about and compare the slopes. So what I would do is subtract a 3y from either side. So I'd be left with 6x x plus 3 equals a -3y. And then I would divide by -3 on either side. So 6x divided by -3 is a -2x, and 3 divided by -3 is a -1, which equals y. So I'm comparing this equation to this equation. So the slope here is 2, and the slope of this second line is -2. So are they parallel? No, because 2 and -2 are not identical. Are they perpendicular? Also no, because they're not negative reciprocals of each other. They're negative, but they're not reciprocals. So this is neither. Example 5 is a problem-solving question, a little bit higher level. If you want to talk that through, I can talk it through with you. Otherwise, the information for that is in your note package. Okay, so go ahead and try some homework, some of the homework 1 on parallel and perpendicular lines. The answers are posted online, and then when you're ready, go try the quiz. Okay? Thanks for listening.